we're going to be evaluating functions. So there's just some terminology that's nice to know. This g of x, that is written or read g of x. And it's not multiplication. Here the g is simply telling you what the name of your function is. Okay, so this notation here, g of 3, it means plug an x value of 3 into the expression and then simplify it. Okay, so we go to the g function. Here we are. And every time we meet an x, we're going to replace it with that value of 3. And then we just simplify the expression. So 6 minus 6 would be 0. So the output is 0 when the input is 3. G of 3 equals 0. And that is equivalent to just an ordered pair. X is 3, y is 0. The input's 3, the output is 0. Okay, let's try the next one. We go to the function g. Here we are. Input a value of 4 in for x. 6 minus 2 times 4. That would be square root of 6 minus 8, which is negative 2. And that is undefined. We're not going to be dealing with complex numbers as we look at functions. We're just looking at the real number system. So that is undefined. Okay, next one, we go to our function g, and every time we meet an x, we're going to replace it with negative 4. So we would get here 6 plus 8, so we would get 14. And remember that notation, g of 4 equals square root of 14, that is a ordered pair. X is negative 4, y is 14. Input of negative 4, output of 14. So it's not an equation here, it's an ordered pair. Okay, let's try another one. So here I need to look for an equation named f, and here it is. Okay, so f of negative 3, that means go to that function of f, copy it down, but every time you see an x, replace it with negative 3. So here we go. And now we need to simplify our expression. Okay, so 2 times 9, and then plus 9 plus 1, we would get 18 plus 10, so 28. And that is not an equation there, that's simply an ordered pair, just saying what is the output. When the input is negative 3, the output's 28. Okay, we can input an x value of 0, that's fine. 2 times 0 squared plus, minus 3 times 0 plus 1. So this all just becomes 0 plus 1, or just 1. Okay, so you can notice here when you put an input of 0 into a quadratic that's in standard form, that output is just the constant, because all of the x's would go to 0. Now we can do this not just with numbers but also with just more expressions. So we go to our function f. Every time we meet an x, we're going to replace it with this whole expression, x plus h. Okay, so here we go. I have met an x. I'm going to replace it with x plus h. Copy the rest of my expression down. Every time I meet an x, I'm going to replace it with x plus h. Okay, so from here I needed an x plus h. From here I needed an x plus h. And everything else just gets copied. Now, remember, we don't have an equation. It looks like it, but this is simply telling us what's being asked. And now on the right side of the equation, I'm showing the work here. So I need to show that I'm going to actually square x plus h. And then distributing that 3, we would get negative 3x minus 3h plus 1. And here I would get x squared plus an xh plus another xh, so there's 2 of those, and then plus h squared minus 3x minus 3h plus 1. And then distributing my 2 to everything, I would get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. and that is the output. Okay, great. So that's the idea with evaluating functions. The common mistake here is to really think of these as if they were equations, because you have all these equal signs, okay? But we just need to keep in mind that over here, this is showing us what's being asked of you in the problem. This is being what's asked of you, and then we have an output of 1. What's in the parentheses, inside the parentheses, that's an x value. Okay, we can do this also from a graph. So input, this is my x value. Okay, so I go to the place on the graph where x equals -3. Here it is. Okay, there's an x value of -3, and I go down and look around and try and find the graph. Okay, so there's a point on the graph where the x is -3, and it looks like the y is also -3. Okay, so when you have an input of -3 for x, you have an output of -3 for y as well. Okay, let's try this next one. So we have a x value of 0, so we go to where x is 0, and we look around and find where that shows up on the graph, which is right here. That point is x value of 0, y value of 2. Okay, so what's being asked of you here is what's the y value, and it is 2. Okay, and remember that this is the same as the ordered pair 0, 2. Okay, we have ordered pair, and then we have that same information in function notation. All right, here I don't know what the x is. That's what I have to figure out, but this, I have a y value of -1. Okay, so I go to my graph where y is -1. There it is. And I look around for my graph. Here I see graph. Okay, and I just need to figure out, well, what's the x value at that point? And that point has an x and a y, actually, of -1. Okay, so that the x there is -1. That's the input you'd need to get for an output of -1. Okay, and you can see here, there's just a big open circle, so there is no y value there. That's not defined. It's just showing that the graph starts really close to that. Okay, x equals -0.999. And now here we have a y value of 1, so we want to know what is the x value that corresponds to that. Okay, well, let's go look. Let's see, a y value of +1. I go up to +1, I look around. This one's not defined because of that open circle, but this one is. It's sitting right there. So the point that's corresponding to that is an x value of 2, a y value of 1. Okay, so we're being asked, well, what is the x value there? And it is 2. Determine the x-intercept. Okay, that is, when does the graph intercept cross the x-axis? And it never does. So there is none. Determine the y-intercept. And that point we actually found right here. And that is at 0, 2. And I could write that in function notation if I wanted to. F of 0, input 0, you get an output of 2. In Connect Math, you're just going to be asked for the ordered pair. All right, let's see, domain. Domain goes from left to right, way back here at -infinity, and we look for graph, and we have graph because of this arrow. My graph continues. So any x value I want to plug in there back at -infinity, I can find a corresponding place on the graph. Okay, and so I keep on going. I've got graph. Oops. Okay, I've got graph. Even here, because it's defined. Okay, and then because of this arrow, my graph continues. Okay, so my domain is all x values from -infinity to infinity. And same with the y, except there's this funny little open space right in here. There's no y values in here. We've got y's going all the way down towards -infinity, and then starting at 1 going up towards infinity. So we need to show that. We would go from -infinity to y to -1. And then there's a little blank spot, and we go up to that y value of +1 and head off towards infinity.